Hi everyone, this is the demonstration video of task 3.3D of SIT 210. I am Sajpal Singh and I done this task with Vipin Kumar. In this task, we need to build an embedded system using the Arduino device and one LED which sends wave signals using the ultrasonic sensor. So before moving forward, let us have some glimpse of hardware.
So my name is Vipin Kumar, and as mentioned earlier, we are using LED ultrasonic sensor Arduino Nano to perform this task. As you can see, I connected the ultrasonic sensor to the Arduino Nano using breadboard and jumper wires. The v- the VCC and ground pin of ultrasonic are connected to the VCC and ground pin of Arduino Nano respectively. Trig and eco pin is connected to D2 and D3 pin of Arduino Nano. This was all about transmitter part. Now coming to the receiver part. This part will be explained by Sahajpal Singh.
Here I connected the LED to the VCC and D2 pin of Arduino Nano using the breadboard and jumper wire. Now this will receive data from the ultrasonic sensor using the MQTT library. So when I bring my hand closer to the ultrasonic sensor, the LED will start blinking. The threshold distance to trigger the LED is less than 12 cm. Now let's come to the software part behind the project.
This is the transmitter code. The code begins by including various libraries depending on the board used. These libraries provide the necessary function for Wi-Fi and MQTT communication. Wi-Fi network credentials like SSID and password are defined. These will be used to connect the Arduino board to the specified Wi-Fi network. The code defines two pins for the ultrasonic sensor, trig pin and eco pin. These pins are used to send and receive signals to measure the distance using the sensor.
Variable Two variables, duration and distance, are declared to store the time duration of ultrasonic pulse and calculate distance respectively. The code initializes a Wi-Fi client and a MQTT client using the previously included libraries. It also specified the MQTT broker's address and port number and the topic to which MQTT message will be published. The code sets an interval for sending MQTT messages. Messages will be sent at this interval if certain conditions are met. An integer variable count is declared to keep the track of the number of times the code enters in the loop. Setup function. Now break down the setup function. This function runs once during the initialize of the Arduino board. It initializes the serial communication for debugging process. It attempts to connect the specified Wi-Fi network and waits until the connection is established. It attempts to connect with the MQTT brokers and hangs if the connection fails. Now come to the loop function. This function will be explained by Vipin Kumar.
The loop function runs continuously after the setup function. MQTT client.poll function. This line allows the MQTT client to handle MQTT communication in the background. MQTT messages are sent at regular intervals determined by interval. Inside the condition block, the following steps are performed. The distance is measured using the ultrasonic sensor by sending a pulse and measuring the time it takes for the echo to return. If the measured distance is less than 12 units, a message is constructed and published via MQTT. The count variable is incremented each time the loop is executed.
Now coming to the receiver code. Just like the transmitter code, the code includes necessary libraries. The libraries provide function for Wi-Fi and MQTT communication. Here the Wi-Fi credentials are same as of the transmitter code. Here I connected with my personal Wi-Fi and mention my SSID and password here. An integer value, an integer variable light is defined and set to 2, which represent the digital pin where an LED is connected. The code initializes the Wi-Fi client and MQTT client just similar to the transmitter code. Now coming to the setup function, as we know, the setup function is run only once. It initializes serial communication for debugging the set and LED pin and LED and sets the LED pin as an output. It attempts to connect the specified Wi-Fi network and waits until the communication is established. This and the whole process is same as the transmitter code. Now break down the loop function. This function will be explained by Vipin Kumar.
Like the transmitter code, the loop function runs continuously after the setup function. MQTT client.pass message function. This line checks for incoming MQTT message and returns the size of the message if one is received. If a message is received that is greater than 0, the code does the following steps. It prints the topic of the received message and its length on the serial monitor. It reads and prints the contents of the message using the MQTT client's read function method. It blinks the LED in a pattern to indicate the reception of a message. Now, LED blinking function will be explained by Sejpal Singh.
So this is the last part of the code. The LED connected to the light pin is blinked in a pattern of on and off states with a short delay in between to provide a visual indicator and when a message is received. So this is the overall demonstration of software and hardware part of task 3.3D by Sejpal Singh and Vipin Kumar. Thank you.